Let's do some more examples of equations that have radicals in them. Say we have the square root of 6x plus 7. That expression, minus 9, is equal to x minus 7. So this works just like the ones we were doing in the other video. Just there's more steps involved. Like I always say, it only gets harder when you create problems with more steps. Now, we know the rule is the first thing we need to do before we square both sides of our equation is we need to get that radical expression all by itself. And so if anything is added to or subtracted from it, we need to use the opposite operation and move it to the other side. So we have square root of 6x plus 7 on the left, and we have x plus 2 on the right. Now once that radical is all by itself, we say I get rid of a square root by squaring both sides. And anytime we square the square root of something, it just leaves us with that something, my stuff underneath. When we square the right side, however, okay, we can't just square the x and square the 2 and keep going on down the road. When we square across a plus sign or a minus sign, it doesn't work that way. Remember that squaring something means we're taking it times itself, which means for a lot of you it would help you out if you wrote them side by side like this. Well, that really means x plus 2 times x plus 2. When we FOIL, we get x squared plus 2x plus 2x plus 4, or x squared plus 4x plus 4. We know when we solve an equation that has an x squared in it, our goal, or the path that we're going to take, is we're going to subtract 6x from both sides. We're going to subtract 7 from both sides. We want to get a 0 on one side before we work with the other. Okay, 4x minus 6x is negative 2x. 4 minus 7 is negative 3. Then when we have an x squared in the problem, we say we can factor, if the polynomial factors, which hopefully it does. All of them in our section here will. And after we factor the polynomial, we set each factor equal to 0, and then we can solve for x. In a sloppy sort of manner like this. Now remember that when we square both sides of the equation, if we've made no mistakes from here to here, x equals 3 and x equals negative 1 are both solutions up here to this equation. But they may or may not work when we check them in the original. Okay, so the rule is we have to check them before we circle them, because maybe they work here and maybe they don't. If we plug in 3 for x, 6 times 3 is 18. I have to put a 3 in for x on this side as well. The statement says square root of 25 minus 9 equals negative 4, or 5 minus 9 equals negative 4, and that's a true statement. So I get to come down here and circle x equals 3. When we plug in negative 1 for x, negative 6 plus 1, or 7, sorry, minus 9 equals negative 1 minus 7. This says square root of 1 minus 9 equals negative 8, or 1 minus 9 equals negative 8. That's a true statement also, which means I get to keep both of these solutions. Both of them are solutions to the equation I was asked to solve. Maybe I have the equation square root of 4x plus 13 plus 1 equals 2x. So we know we're going to have to square both sides of the equation because there's a radical involved right here. Okay, a square root specifically. But we know we're not going to square both sides of the equation until we have that radical expression all by itself. So first we're going to subtract the 1 from both sides. Now that the radical's by itself, we can square both sides of the equation. On the left, we'll just have 4x plus 13. Hopefully it'll let me move down. Up here, if we write 2x minus 1 side by side, if we FOIL and we combine our like terms, or maybe we don't, but we have 4x squared minus 4x plus 1, or you could have a negative 2x and negative 2x here. When I see an x squared in the problem, I know that I want to get a 0 on one side, so I can factor the other. And this says 0 equals 4x squared minus 8x minus 12. If I want to get this right side factored, I could start by taking 4 times negative 12 and find the factors of negative 48 that add to be negative 8. Okay, or the shorter path to take is if I notice the greatest common factor of all of those terms being 4. I say, I can factor x squared minus 2x minus 3. It might even be the same one that I just factored in the other problem. If the product of 2 or more numbers, I have 3 of them here, if the product is equal to 0, I know one of them has to be equal to 0. Okay, 4 is not 0. 4 is not a variable. So 4 has no effect. It doesn't lead us to any solutions. 4 is just 4. So we know the 0 either comes from here or from there. That means our two possible solutions, again, are positive 3 and negative 1. And again, while those numbers are solutions to this equation right here in the middle, the one that does not have a radical in it, they may or may not work when we take them clear back up to the top. So if I plug in 3 for x, it says 12 plus 13 under the square root plus 1 equals 2 times 3, which is 6. It says the square root of 25 plus 1 equals 6, or plain old 5 plus 1 equals 6. That's a true statement, so we're going to keep x equals 3. Okay, deja vu, I feel like I just did this. When we plug in negative 1 for x, we get negative 4 plus 13 under the square root plus 1 equals 2 times negative 1, which is negative 2. That says square root of 9 plus 1 equals negative 2, or 3 plus 1 equals negative 2. Okay, that's not true, which means negative 1 is not really a solution. So the only solution to this equation here, the one that we started with, that we were asked to work with and copied out of the book, okay, or off the board from me, the only solution is x equals 3. Don't forget to check your solutions. It's a requirement here, not just a recommendation, because sometimes they both work. Sometimes only one of them works. Sometimes the solutions we think we have don't work at all.